Warning: potassium bromate, potassium dichromate, and bromine are strong oxidizers. Potassium dichromate and bromine are very toxic. Bromine vapor is very corrosive. Wear gloves and goggles at all times, and wear a respirator when dealing with bromine. Hi guys, here is MIH. In our last video about making nitric acid from chromium nitrate, we produced a lot of chromium oxide as a byproduct, and today I'm going to turn it into potassium dichromate, a very useful oxidizing agent. Now, making dichromates has two conventional routes, which are liquid phase oxidation and solid phase oxidation. Both methods reuse a base and an oxidizer to oxidize the chromium to chromates, and acidifying the chromate solution gives a dichromate. However, those methods require significant amounts of base and acid, which contradicts to the principle of green chemistry, and the resulting salt is hard to separate from the dichromate. I have also used another way involving anodic oxidation of chromium metal, and the link is in the video description. The problem with this method is that chromium metal is not widely available. So today I'm going to introduce a method that directly produces potassium dichromate without any alkali or acid, which is reacting chromium oxide with potassium bromate in water. The only byproduct of the reaction is bromine, which is a tremendously useful compound as well. Therefore, we can fit the synthesis of potassium dichromate in the frame of green chemistry. Let's get started. I first added some water to the waste from last time and decanted it off to see if the waste has any hexavalent chromium in it. The color of the water is a dark brown, and it didn't react with acidified sodium sulfite, so there are no hexavalent chromium. I then measured out 61.24 grams of potassium bromate that I made myself by electrolysis directly into the wastewater. I stirred the mixture around to dissolve the bromate. I then transferred both the solid waste and the wastewater into a 500 ml conical flask. I then built a distillation setup identical to the setup I used in my nitric acid video, and I started to heat the conical flask with my hot plate. The bromine will only form near boiling, and the brown color you see here is just the chromium oxide suspension. Soon, the mixture began to boil and release a bunch of red-brown vapor, which is clearly bromine. In the condenser, we can already see some orange bromine water distilling over. 5 minutes later, some more bromine came over, and bromine vapor begins passing through the collection bottle and into the alkali trap. I somehow really loved watching bromine condensing in the condenser. It's just so mesmerizing to me to see the brown deadly liquid flowing down and getting collected. Around 15 minutes later, a lot of foaming was observed in the conical flask, and the bromine color fades in the upper part of the condenser. The water is now distilling over and pushing the bromine vapor towards the collection bottle, which you can see is starting to collect some bromine. The alkali trap was also overloaded as a bunch of bromine vapors escaped out of it. I quickly dumped in some more potassium hydroxide in the trap to totally absorb the bromine vapor. 10 minutes later, the rate of distillation slowed down, and we can see that we have around 10 ml of scary bromine with 30 ml of water collected in the condenser. The collection bottle also has some bromine in it. I then added around 50 ml of water to the conical flask and distilled again. Here you can clearly see the water vapor slowly pushing the bromine vapor downwards in the condenser, which I thought was really cool as well. After a while, I let the conical flask cool and disassembled the apparatus. You can see the blood red solution of potassium dichromate in the conical flask. All of the stoppers and tubings used in the apparatus are soaked in an acidic thiosulfate bath to destroy all traces of bromine and dichromate. After some dangerous workup I wasn't able to film, I'm left with around 5 ml of bromine as a dark red liquid. I didn't measure the exact yield because the bromine is not my desired product, and its vapor is really just too irritating to handle properly. I have to place a beaker with concentrated ammonia beside the bromine container when transferring it to prevent breathing in the bromine vapor. The bromine was immediately used in an organic test experiment you will see soon. Anyways, now I'll recover our main product, potassium dichromate, from the blood red solution. I first moved my hot plate outside since the solution still contains some bromine that will be released when boiling it. I also don't want any dichromate to splash on my lab table. I poured all of the dichromate solution into a 250 ml beaker and boiled it down until its volume reduces to 125 ml. I took it off the hot plate and let it cool down, and a bunch of red potassium dichromate crystals separates out. They actually look quite pretty, but remember that very beautiful things are often equally dangerous. I quickly set up a gravity filtration apparatus and poured the supernatant into it. The remaining crystals may seem dry, but still contains a bunch of water, so I stirred it with a spatula to release the remaining water. You can see that some brown junk was left on the filter paper, so I removed it and switched for a new one. By the way, anything that came in touch with the dichromate, such as the conical flask, the filter paper, and some paper towels I used for cleanups, were immediately thrown in an acidified thiosulfate bath to destroy the dichromate. I then moved the crystals inside the new filter and waited for the remaining water to pass over. You can see me pouring the reducing solution into the beaker, and the dichromate color quickly disappeared. After the crystals dried for a bit, I transferred them to a plastic beaker. The final weight of our product is 41.91 grams, which represents a yield of 57.0% based on the initial chromium nitrate I fed in my nitric acid video. This may seem low, but remember that we lost a fair bit of chromium in the various transferring steps with the chromium oxides and the dichromate, and there are still some dichromate left in the filtrate, which hopefully will crystallize out and get recovered as well. See you soon!